It's not just durable, it repairs itself. Modern concrete cracks after only 50 years, but this concrete has lasted for over 2 millennia. How on earth did the Romans create a material that actually heals itself? Welcome to the Origin Pulse today. We're unlocking the secrets of one of history's greatest engineering marvels, Roman concrete. This is the material that formed the very backbone of an empire. We see it in legendary structures like the majestic Colosseum, the breathtaking Pantheon, and the sprawling aqueducts that crisscross the landscape, all of which are still standing strong after more than 2,000 years. For decades, scientists knew this material was special. They observed its incredible resilience, particularly when submerged in seawater, a notoriously harsh environment for modern concrete. But the exact reason why it was so durable remained a mystery. The answer, as it turns out, was hiding in plain sight, mistaken for a simple flaw. If you look closely at a cross-section of Roman concrete, you'll notice these tiny, white, mineral-like chunks scattered throughout the mixture. For years, experts dismissed them as evidence of poor mixing or low-quality materials. They were called limeclasts. But recent breakthroughs from researchers at MIT and Harvard have revealed a stunning truth. These weren't a mistake at all. They were a deliberate, ingenious addition. The leading theory now is that these are not just chunks of standard lime. Instead, they are remnants of quicklime or calcium oxide, which was added to the mixture in a process now known as hot mixing. When the Romans combined their ingredients volcanic ash known as pozzolana, aggregates like rock and sand, and water, they likely added This would have triggered an exothermic reaction, significantly raising the temperature of the entire concrete slurry. This high heat process created unique chemical compounds and left behind these pockets of highly reactive quicklime embedded within the final structure. And here is where the real magic happens. As the centuries pass, tiny, inevitable cracks begin to form in the concrete. When rainwater or moisture seeps into these fissures, it finds its way to one of those reactive limeclasts. The water reacts with the calcium oxide, causing it to dissolve. Then, through a natural chemical process, it recrystallizes as calcium carbonate. The same material found in limestone and seashells is effectively filling the crack from the inside out. The concrete literally heals its own wounds. This incredible self-healing mechanism works on a microscopic level, constantly repairing minor damage before it can grow into a major structure-threatening fracture. It's this constant, autonomous repair that has given these ancient structures their unbelievable longevity. While a crack in modern concrete is often the beginning of the end, for Roman concrete, it was just the start of a healing process. It's astonishing to think that this revolutionary knowledge appears to have been lost after the fall of the Roman Empire. For over 1,000 years, builders and engineers couldn't replicate the durability and resilience of their ancient predecessors. The formula for self-healing concrete seemingly vanished from history, leaving behind only the enduring monuments as a testament to its power. But now, the rediscovery of this ancient wisdom is sparking a revolution in modern materials science. Today, scientists and engineers are drawing inspiration from the Romans to develop a new generation of smart, sustainable building materials. They're studying the precise chemistry of hot mixing and the role of limeclasts, hoping to create self-healing concretes for our own time. This isn't just about making stronger buildings, it's about making them more sustainable. The production of modern Portland cement, the key ingredient in today's concrete, is responsible for about 8% of global CO2 emissions. The Roman hot mixing technique, which could potentially create stronger and longer-lasting concrete at lower temperatures, offers a promising path toward a greener construction industry. If we can build structures that last longer and require fewer repairs, we reduce the environmental footprint over the building's entire life cycle. The Romans weren't just master builders, they were brilliant, intuitive material scientists. Their 2,000-year-old recipe holds secrets that are more relevant today than ever before. By looking back at this ancient wisdom, we might just find the key to building a more durable and sustainable future. The legacy of Rome isn't just carved in stone, it's chemically bonded into the very material that could help us shape tomorrow. Thank you for joining us on this journey back in time. If you enjoyed uncovering this ancient secret, make sure to subscribe to the Origin Pulse and hit that notification bell so you don't miss our next exploration.